Chlorine dioxide, or CLO2, is an extremely powerful oxidizing agent, microbiocide, viricide, bactericide, protocide, and algicide. It disinfects through oxidation. However, unlike other oxidants, it does not produce chlorinated byproducts. Specifically, it rapidly kills microorganisms by disrupting the transport of nutrients across the cell wall. It is very important not to confuse chlorine dioxide with chlorine, as these are two distinct chemicals which react very differently and produce separate byproducts with little in common. Traditionally, chlorine dioxide is used for bleaching and paper manufacturing and has been used on a large scale to disinfect municipal drinking water since 1956. The EPA has since registered its use for food processing, including fresh produce and meat, and the sterilization of clean rooms and laboratories. Biofilm is the layer of slime containing bacteria and other organisms that builds up on the inside of water pipes and equipment. This layer of slime protects bacteria and other disease-causing organisms from sanitizers and chemicals. Chlorine dioxide is effectively used to control biofilms in water distribution systems and for the control of Legionella bacteria. Chlorine dioxide is extremely effective against waterborne pathogenic microbes such as viruses, bacteria, and protozoa. As administered and overseen by SABRE, chlorine dioxide can also be used for air sterilization and was the principal disinfecting agent used for the decontamination of affected buildings after the 2001 anthrax attacks. Chlorine dioxide was also used by SABRE to eradicate dangerous mold from houses inundated by the floodwater after Hurricane Katrina. The generation of chlorine dioxide involves the controlled eduction of sodium hypochlorite, hydrochloric acid, and sodium chlorite into either a reactor or fluid stream where the chlorine dioxide is formed. Hydrochloric acid is first reacted with sodium hypochlorite to form molecular chlorine. Molecular chlorine is then reacted in the second column stage with sodium chlorite to form chlorine dioxide. Chlorine dioxide is a true gas, which means that it retains its chemical structure and properties at all times. Chlorine dioxide does not form another compound when introduced to water or other solvents. No matter what chlorine dioxide is dissolved in, it retains the same structure and reactive properties. And because it is extremely soluble in many fluids, including water and hydrocarbon, it can penetrate through material that protects microorganisms from other biocides. Chlorine dioxide is also a free radical. In other words, chlorine dioxide has an unpaired electron in its outer shell. As a result, whatever chlorine dioxide can react with, it will do so instantly, regardless of the temperature or concentration. The SABRE companies specialize in chlorine dioxide applications that eliminate and control biological and chemical contamination. The company's significant history and numerous patents on chlorine dioxide generation and process technology provide the framework for unique solutions to many industries, including oil and gas, environmental, and municipal treatment. SABRE Energy Services LLC specializes in providing surface and subsurface biological control services for the oil and gas industries. These services include chlorine dioxide treatment for wells downhole and surface water applications, including the treatment of fresh water, produced water, and hydraulic fracturing frac water. SABRE's technology also provides polymer removal, solids and oil separation, and is an effective solution to corrosion and souring and other problems related to sulfate-reducing bacteria, hydrogen sulfide, iron sulfide, and bacteria and biofilms. For over 2 decades, SABRE has used its patented technology to improve field performance in water treatment and dramatically increase reuse of water, reducing costs and environmental impacts.